So when we're naming ionic compounds, we need to remember that an ionic compound is made of a combination of a cation and anions. So we will of course need to know how to name cations as well as how to name anions to put them together for the name of the whole compound. Now before we get into the naming, let's remember what is a cation. A cation is a particle that has a positive charge, and a cation can either be a monoatomic cation or a polyatomic cation. Monoatomic cations will be those that come from metal atoms. For example, sodium atom can make a sodium ion cation with a positive charge, or a aluminum atom, which is again a metal, can make an aluminum cation, and both of these are monoatomic because one atom is needed to make each of those cations. But cations can also be polyatomic if more than one atom comes together to make a bigger unit that has an overall net positive charge. And the one that you really need to be aware of for now and be careful of and remember to recognize is the ammonium cation, the NH4 plus cation. Cations will fall under two different categories for the purpose of naming. The first category is called the fixed charged cations. These are cations whose charge, the magnitude of the positive charge, never changes. The magnitude of the positive charge is the same in all compounds where this cation exists. These you need to know. You need to know which metals in the periodic table will make fixed charge cations, and therefore you will be able to predict the magnitude of the positive charge on those cations. These are all group 1A metals will have a charge of +1 because all of them have one valence electron. They are all main group elements, and when they react with a nonmetallic element, they do so by donating that one valence electron to the nonmetal and therefore have a charge of +1. So you do need to remember this. All group 1A elements will will make a cation with +1 charge. All group 2A metals will also make fixed charge cations with charges equal to +2. In group 3A though, aluminum makes a fixed charge cation and so does gallium, but not the other metals. Those do not make those do not make cations for whom the magnitude of the positive charge can be predicted. Besides these main group metals, there are a couple of transition metals that also make fixed charge cations: zinc, cadmium, and silver. You need to remember this. You need to memorize it or whatever you need to do in order to remember that group 1A metals will always make a cation with +1, group 2 with +2, aluminum will have a charge, ion will have a charge of +3, gallium ion will have a charge of +3 as well. Those, of course, you can predict from the periodic table as we did before, but zinc cation will have a charge of 2+, cadmium cation will also have a charge of 2+, silver cation will have a charge of +1. These you need to memorize. Besides the fixed charge cations can be variable charge as well. These are cations where the same metal atom can actually make two different cations where the magnitude of the positive charge is different. Let me give you an example. Copper can make a cation with a charge of copper +1, but it can also make, depending on conditions, make a different cation with a charge of +2. Because of that, these are called variable charge cations, and you cannot predict the magnitude of the positive charge from the periodic table. You cannot. Another example is iron. Iron can make again a cation where the magnitude of the charge is +2, or make another one where the magnitude of the charge is +3. Once again, these cannot be worked out, cannot be predicted based on the position of iron in the periodic table. So any metal, or I should say all metals in the periodic table that do not make fixed charge cations make variable charge cations. So if you know the metals in the periodic table that make fixed charge cations, you automatically know the others as well. So please make a note of these. Okay, so if you have decided that your compound is a combination of cations and anions, in other words, it's an ionic compound, and then you've decided that the cation in the compound is a fixed charge cations, we need to now know how to name this compound. These compounds are named following very simple steps. The cation is named first because it appears in the chemical formula first. The cation for such compounds is named simply by naming the metal that was used to make that ion. Following that, we then name the anion as a separate word. We name the anion by taking the name of the non-metallic element that makes that anion. We take the stem of the name and then attach the suffix "ide." And I'll show you what we mean by that in just a minute. If the anion or the cation are polyatomic, then we do not change the name of the polyatomic ion and keep it just as such. So let's try these out. Let's see how we use these steps to name such compounds. Here's a chemical formula. First question you need to ask yourselves, is this an ionic compound? Yes, it is an ionic compound because it has calcium in it, which is a metal which would make a cation. And if that's a cation, then sulfur, being the non-metallic element, will make the anion. Please remember, if there's a cation, there will be an anion. But if there is no cation, there cannot be an anion. Okay, so now next question we need to ask ourselves is, what kind of a cation is it? Is it a fixed charge cation or a variable charge cation? Calcium belongs to group 2A, and as we said earlier, all group 2A metals make fixed charge cations. What would be the charge on calcium ion? Exactly. The charge on calcium ion will be 2 plus because it's in group 2A. It has 2 valence electrons which would need to be donated in order to satisfy the octet rule. How do we name this cation? We name this cation by simply using the name of the element calcium. So that's the name of the cation. Let's now talk about the name of the anion. The anion in this case is sulfur with a charge of 2 minus. Now there are two different ways of figuring that out. One, of course, is directly from the periodic table. We know that sulfur is in group 6A. It's a non-metallic element, so it will need to accept 2 electrons in its valence shell to satisfy the octet rule. Hence the charge is 2 minus. Another way that you can figure out the same thing is by looking at the chemical formula. If the chemical formula of the compound is CaS, and we know that calcium has a charge of 2 plus, and overall the charge of the formula unit should be 0, then what should be the charge of the anion? 2 minus, exactly. So either way you figure it out, you get the same answer. So if the anion is sulfur S2 minus, then how do we name this? As we said, we take the name of the anion element, which is sulfur, and then we take the suffix out of there. So sulfur is the original name of the element. We take the suffix out, we cross this out, and add a new suffix IDE. Whenever you hear a name ending with an IDE, that will, for most part, indicate a monoatomic anion. There are a couple of exceptions to this rule. Those couple of exceptions are polyatomic ions hydroxide or cyanide, the ones that you had to memorize in the previous sessions. So those you just have to know that if it's a hydroxide or cyanide, even though it's ending with an IDE, you have to remember that it's actually a polyatomic ion. Except for these exceptions, ide anions represent monoatomic anions from that corresponding element. Okay, so in this case, sulfur becomes sulfide. Therefore, the name of the compound is calcium sulfide. Okay, let's try out more. Here is another one, K3N. Once again, please go through the process. Is this an ionic compound? Yes, it is an ionic compound because we have potassium, which is a metal that will make a cation when making a compound. So if there's a cation, there will be an anion, and hence it's an ionic compound. Okay, now what kind of a cation is it? Is it fixed charge or variable charge? Potassium is a metal in group 1A, therefore it has to be a fixed charge cation. So we are now ready to name this compound. The cation in this case is potassium with a +1 charge. The anion in this case is nitrogen. Any guesses what the charge is going to be on the anion? Exactly, 3-, and now we name it. Okay, so the cation has to be named as the name of the element, which is potassium. The anion is named from the name of the element, which is nitrogen, but we cross out the suffix and add a new suffix, IDE. So when you do that, the name of the compound therefore becomes potassium nitride. Okay, so why don't you go ahead and name the rest of the compounds as well. You may pause the recording for a few minutes while you finish that. If you can name a compound based on from the chemical formula of the compound, we should also be able to write the chemical formula of the compound from its name. It is very important to be able to do both. So if the name of the compound is given as silver sulfite, what would be the chemical formula for this compound? So let's work backwards and figure this out. So what is the cation in this compound? The cation is silver ion. Would silver ion be a fixed charge cation or variable charge cation? Exactly, it's a fixed charge cation, and from the previous slide, what would be the magnitude of the plus charge? +1. So the cation in this case is silver plus. What is sulfite? Now earlier on I said ide ions, or any ion whose name ends with an IDE, are mostly monoatomic anions. And there were a couple of exceptions that we wrote, except hydroxide or cyanide. But then this anion is ending with ITE. So anion names that end with ite or ate, these without exception are always polyatomic anions. So you need to remember, you need to notice the ITE and then remember that has to be a polyatomic anion, and then from there decide what is this polyatomic ion. You had to memorize the list of polyatomic ions from your book. So if you've done that, you would immediately be able to remember that sulfite is SO3 with a charge of 2-. Now, what would be the chemical formula if you had to put these two ions together in a ratio such that the overall charge was 0? Exactly. You would need two silver ions to balance out the negative charge of one sulfide ion. So the correct chemical formula for this compound will be Ag2SO3. So please do remember these hints that I am pointing out along the way, because they will help you name compounds or write the chemical formulas. So please pause the recording while you go ahead and write the chemical formulas of the remaining ones on your own. If you've done them, you probably have the same answer as mine. Please make sure you understand each of them and are able to carry this out. Now, before we end this session, I want to ask you a quick question. If I gave you a chemical formula, let's say I gave you this formula, ZnHCO3 twice. And the question I was going to ask you says, identify the ions in the following. And this was the compound or the chemical formula given. How would you do that? Now please remember, as I said earlier, when you're writing an ion, it is not enough to just write the symbol of the element. You must give the charge as well. So the correct way to answer this question would be to give the cation with its charge. Now what do you think is the charge on the cation in this case? Exactly, it's 2 plus, and the anion with its charge as well. This of course has a charge of -1. So let's try this out again with a different compound. So identify the ions in let's say first of all, what do you think is the name of this compound? Is this an ionic compound? Yes, it is an ionic compound. Is it a fixed charge ionic compound or a variable charge ionic compound? Yes, it has a fixed charged cation. Okay, and then how would you name this compound? You would name the cation first, which is aluminum. And then you would name the anion, which in this case is a polyatomic anion, as you can tell, and that polyatomic ion is called sulfate. Agreed? Now if I asked you to identify the ions, then the cation in this case is aluminum. Is that correct? No, it's not, because Al does not give me the ion, it only gives the atom. So I must give the charge. And the anion is the sulfate anion. Once again, without the charge, it's not an ion. You have to make it very specific.